Alright, make sure that you have your Learning Target 4 notes out in front of you, and let's go ahead and talk about define and evaluate functions using function notation. Alright, so when an equation is a function, as you know, it has to have one output for each input. Alright, we can write the equation using f of x equals instead of y equals. So f of x is what we call function notation. Right? This means that the function is called f, and we are going to put different values of x into it. However, you can use different letters besides f and x depending on what you want to call it and what you want to put into it. This is helpful if we are working with more than one function. So the two main benefits of using function notation are when you have more than one function. It distinguishes them. So you can say it's f of x, or it's g of x, or it's c of x, or anything like that. And the other one is when you have more than one variable. So if you have like g of x, or you have m of a, or any of those, that would be when you would want to, that's a big advantage to having it in function notation, right? So let's go ahead and consider the following functions. We've got these three functions: f of x equals 3x plus 1, g of x equals x squared minus 3, and h of x equals 10x, right? Using these functions, fine. So f of 4, what we're going to do for this situation is we are going to take the 4 and we're going to plug it in for x. So f of 4 is 3 times 4 plus 1. So substitute 4 in for x and evaluate. And then and we can evaluate this one. So f of 4, let's write this over here, f of 4 equals 3 times 4 is 12 plus 1 is 13. So h of negative 2. So now we're going to take the negative 2 and plug it in for the x right here. So it's going to be h of negative 2 equals 10 times negative 2. So h of negative 2, I'm sorry, that should be a 4 right here. F of 4 equals 13. So h of negative 2 equals negative 20. And then for g of 5, we're going to plug the 5 in for the x here. So that is going to be 5 squared minus 2. 5 squared is 25. 25 minus 2 is 23. So g of 5 equals 23. Alright, so that's when we're just plugging it in for the x value here. We plug it in over here and we just evaluate it. Down on these last two, it's a little bit different. We want to find x when f of x equals 64. So if we look at this situation, I'm going to take this 64 and we're going to plug this 64 in for f of x. Not for x, but for f of x. So I'm going to rewrite this as 64 equals 3x plus 1. So again, I'm putting the 64 in for f of x right here, not just for the x. Right? And then I'm just going to evaluate it. So just like we do with all our two-step equations, I'm going to minus 1 after I circle the variable and draw the line from both sides, and I get 63 equals 3x. And then I'll divide by 3, and I get 21 equals x. So we just figured out what? We found x when f of x equals 64. Now let's do the same thing for h of x equals 12. So again, we're going to take the 12, and in this case, we're going to put it in for the h of x. So I'm going to put 12 in equals 10 times x. We don't know what x is, we're trying to find x. So then to solve this, we divide by 10, and 12 divided by 10 is 1.2 equals x. So that is evaluating a function using function notation. And we're evaluating it when we're given what f of x equals, or h of x, but we're also evaluating it when we're given what the x value is, right there. Right? So that is Learning Target 4 notes.